Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. If you can recall, in the last class we had started with 8086 assembly directives. Assembly directives are basically directions that are given to the assembler which indicates how an operand or a section of program is to be processed. Mind you, assembly directives are never translated into machine code by the assembler, so that's the reason why assembly directives are also called as pseudo operations. If you can also remember, we had started with some of the notable assembly directives in 8086 microprocessor. So we had started with assembly directive segment, then we moved on to end segment directive, then we discussed end directive, then we moved on to assume directive, then we discussed define byte directive, then we moved on to define word, then we moved on to define double, and then we discussed define quadruple word, and then we discussed define 10 bytes. Now, moving ahead, we will discuss the purpose of the assembly directive equate. Now, equate is represented with the help of EQU. So, EQU is used in order to give name to some value or to a symbol. Again, I'll repeat it. Equate is used in order to assign name to some value or symbol. So, each time the assembler finds this particular name in the program, it replaces the name with the value or the symbol you had equated the name with. For an example here, I have equated the name factor 203H at the start of the program. So whenever this particular name will be encountered in the program, it will be equated to 03H. So here I've taken up a statement. Add AL comma factor. So when the assembler codes this instruction statement, it will code it as if we have written add AL comma 03H. So this is the purpose of equate. Now the next assembly derivative that we have is called as length. Now length is an operator that will tell the assembler to determine the number of elements that are present in the named data item. For an example, it can be a simple variable or it can be a composite variable like an array. So a string is also a collection of characters, so string is a character array. So length is capable of determining the number of elements that are present in the named data item. Let us try to understand the purpose of length with the help of a very simple example. So here I have written a statement move cx comma length string 1. So now this length here will determine the number of elements that are present in the variable string 1 irrespective of the type of string 1. So again I am repeating it, it will be irrespective of type of string 1. So it will determine the number of elements that are present in string 1 irrespective of the type of string 1. So whether it's of type double or whether it's of type word or whether it's of type byte, it will determine the number of elements that are present in string 1. Now offset. Now offset is an operator that will tell the assembler or that will indicate the assembler to determine the offset of the data item with respect to the base address of the segment. So it will determine the offset of the offset or the displacement of named data item or a procedure from the start of the segment. Now here I have written a very simple statement move bx comma offset of prices. So now this offset directive here will determine the displacement of prices from the base address of the segment where prices have been prices have been specified, right? Okay, so what it will do, it will determine the displacement or offset of the data item price from the base address of the segment where it has been defined. So that is the purpose of the assembly derivative offset. Now likewise you have another assembly derivative that is called as PTR, which stands for pointer. So the pointer operator is used to assign a specific type to a variable or label. Again I will repeat it, the pointer type is used in order to specify in order to assign a specific type to a variable or label. Now, why is it necessary? It is necessary in situation where it is difficult for one to interpret the type of the operand. Again, I'll repeat it. It is used in situation where it's difficult to interpret the type of an operand. So let us try to understand it with the help of an example. So here, if I've written a statement inc bx, so now here it will be difficult for one to interpret what kind of incrementation is to be done on the memory location pointed to by bx, whether it's a word increment or a byte increment. So in order to facilitate this, the statement can be replaced suitably with int byte ptr bx. So it implies that we are trying to increment the byte that is being pointed to by bx. Likewise, if I want to increment the word pointed to by bx, I need to write increment word ptr bx. So it will increment the word that is being pointed to by bx. Now the even directive. The even directive, as the name says, it is used in order to make the location pointed point to the next even address. For an example, whenever you want to place an instruction or data onto the next even address, what I can do is I can use the even directive. So even directive is used in order to place the or make the location pointer point to the next even address. So as an assembly assembles a section of data declared or instruction statement or an instruction statement, it uses the location counter to keep track of how many bytes it is moved from the start of the segment at any point in time. So the even directive tells the assembler to increment the location pointer to the next even address. Now, the next assembly directive that you have is called as procedure. Now, procedure is directive is used in order to mark the beginning of a of a procedure. So, the procedure directive follows the name given to a particular procedure. So, procedure is not is a sequence of statement that is capable of performing a specified task. So, procedure is used in order to mark the beginning of the procedure. Now, you need to always ensure that the procedure terminates with the help of NP directive. So, NP directive is used in order to mark the end of the procedure. So, procedure along with NP is used in order to encapsulate a procedure. So, whenever you're using procedure directive, the procedure directive has to be followed by the name of the procedure. So, if I want to have a procedure by the name add, so it will be add procedure. So add PROC. Here I've given a divide procedure, so it's a divide procedure. So this is the way how procedure works. So procedure is used in order to mark the beginning of a procedure in a program. Likewise, NP directive. So NP directive is used in order to mark the end of a procedure. So here I have started a procedure by the name square root. So NP is used in order to end the procedure in a manner. You need to specify the procedure name and NP. So square root NP marks the end of the procedure. Now extern. Now extern is an assembler directive that is used in order to tell the assembler that the name or the label that is following this particular directive is in some other assembly module. So we can have multiple programs residing in the memory. So if you want to call a procedure that belongs to some other procedure or data that belongs to some other programming module, then you need to use extern. So extern will let the assembler know that the referred to module or data item is present in some other program that is residing in the memory. So that is the purpose of extern. Now the next assembler data that we have is called as public. Now the public directive is used in order to tell the assembler that the specified name or label will be accessed from some other module. So there might be multiple procedures or data items that you want to access in the current module. So in order to that belongs to some other module, or that belongs to some other belongs to some other part of the program. So in order to facilitate that, what we can do is we can use public directive in order to tell the assembler that the specified name or label will be accessed from some other module. So that is the purpose of a public directive. Now short. Now the short directive or the short operand is used to tell the assembler that only a 1 byte displacement is needed to code a jump instruction in the program. So the destination must be in the range of -128 byte to 127 byte from the address of the instruction after the jump. So here that is the purpose of the short operate and the short directive. So the short operator is used to tell the assembler that only a 1 byte displacement is required. Now likewise, the next assembly data that we have is called as type. So the type operator tells the assembler to determine the type of the specified variable. So the assembler actually determines the number of bytes in the type of the variable. So for a byte type variable, the assembler will give you a value 1. For a word type variable, it will give you a value 2. For a variable of type double, it will give you a value 4. So it can be used in the instructions such as, so here I've cited an example, add bx comma type of word underscore array. So where we want to increment bx to point to the next word in an array of words. So this is a very simple example how you can use type. But you remember, type operator tells the assembler to determine the type of the specified variable. Now, the next assembly directive that you have is called as global. So the global directive can be used in place of a public directive or in place of an external directive. For a name or a symbol defined in current assembly module, the global directive is used to make the symbol available to other modules. So that is the purpose of the global assembly directive. So global assembly directive again can be used in place of public directive or in place of external directive. Now the next assembly directive that we have is called as include. So the include directive is used to tell the assembler to include a block of source code from the file name specified into the current source module. So the way how we include stdio.h file in C program, the similar manner include is used in order to include source code from some other location in the memory. So this is the purpose of include. So these are the basic assembly directives that you have in 8086. So if we can recall, so we had started with segment, then we moved on to end segment, then we discussed end, uh, significance of end, then we moved on to assume, then we discussed define byte, we moved on to define word, we moved on to define double, then we discussed define quadruple word, then define 10 bytes, then we moved on to equate, then we discussed length, offset, pointer, even directive, then we moved on to procedure, end procedure, extern, public, short, type, global, and eventually include. So these are the basic assembly directives that you have in 8086 microprocessor. So thank you very much. Have a very good day.